If you've ever taken shop class in high school or watched an episode of How It's Made, you probably have some idea how lathes and other metalworking machines function. As technology and computers have improved over the years, a new high-precision computer-controlled manufacturing technique called CNC machining has spawned. CNC machines, or computer numerically controlled machines, are electromechanical devices that can manipulate tools around a varying number of axes, usually 3 or 5, with high precision per instruction from a computer program. CNC machining is one of two ways that engineers, machinists, or makers can generate a physical part from a computer design file, with the other being 3D printing, known as additive manufacturing. The contrast between these two techniques is stark. CNC machining, like other machining processes, is a subtractive process, where material is removed from a stock. 3D printing, on the other hand, is an additive process, essentially functioning in reverse. The first CNC machines were developed in the 1940s and 50s and relied primarily on a data storage technique known as punched tape. The code to control the machines would be manually punched into a data card and fed into a system that would then interpret the data. Needless to say, these early machines were rudimentary and their functionality was limited. CNC machining technologies rapidly grew as technological capability only accelerated in the late 20th century, which brings us to how modern CNC machines work. As mentioned before, machining is a way to transform a stock piece of material such as aluminum, steel, or titanium into a finished product or part. CNC machines rely on digital instructions, specifically referred to as G-code. Before modern computer-aided manufacturing and computer-aided design programs such as Autodesk's Fusion 360 were around, machinists would manually write the G-code to control these machines. CAM programs today allow you to take a 3D model and automatically generate G-code that will drive the machine with little input. When you compare the capabilities of automated CNC machining to the manual alternative like lathes and other machining techniques, you can start to see the benefits. CNC machines simply run faster at higher precision and accuracy while simultaneously allowing the transformation of a digital design into a physical part. CNC machines are precise and are measured in thousandths of an inch, referred to as thou. Standard machining can provide tolerances on parts around plus or minus 0.005 inches. Fine machining can produce tolerances of about plus or minus 0.001 inches, and specialized processes like polishing can offer up repeatable tolerances as tight as plus or minus 0.00005 inches. For reference, a human hair is 0.00069 inches thick. Now that we have the basics of CNC machining out of the way, we can start to dig into the intricacies held within. Many designs or specific machining processes require the use of multiple tools to make cuts. One tool doesn't function universally. For this, machinists will often build digital tool libraries that interface with the physical CNC machine. These machines, often costing hundreds of thousands of dollars, can automatically switch tooling when directed by their digital instructions, allowing for them to become manufacturing workhorses. Basic CNC machining will move one or two axes, referred to as the x-axis and the y-axis. You'll often hear the terms 2.5-axis, 3-axis, and 5-axis CNC machines, which simply refer to the degrees of freedom a machine can make cuts in. A 3-axis machine will move in the x, y, and z axis, whereas a 5-axis machine can move in these 3 axes along with 2 additional rotational axes. As you might be able to imagine, the possibilities of production with 5-axis machines are practically endless. 5-axis machines used to be relegated to high-precision work, but as they have become more affordable, they are quickly becoming standard in many shops. There are 3 conventional machining technologies that you need to understand to grasp the basics of how material is removed from stock in CNC machines. The first being drills. Drills work by spinning a drill bit and moving the bit into contact with a stationary stock. Next, we have lathes, which function in reverse to drilling. Lathes spin the block of material against a stationary drill bit or cutter to remove material in a circular or fluid path. The shape capabilities on lathes are more limited than other techniques, but modern technology does allow these machines to create things such as square holes or non-circular shapes. Lastly, the most common CNC machine type is referred referred to as a milling machine. Milling machines involve the use of rotary cutting tools to remove material from a stock piece. These machines function similar to drills, with their tooling capabilities encompassing much more variety. Almost any material can be used in CNC machines, from plastic to titanium. Different materials have different properties, so machinists and engineers will overcome their unique challenges by altering machining variables like tool selection, RPM, feed rate, and coolant flow, among an extensive variety of other factors. CNC machined parts are all around you. They hold together your car and perform vital functions aboard SpaceX rockets. CNC machining is arguably the only way to produce high-precision metal parts for engineering designs across the world. If you're interested in learning more about CNC machining and the crucial trade that it is, one of the best places to do that is through the Titans of CNC Academy. This online resource will teach you from the ground up how to design parts and machine them for free, whether you have a CNC machine or not. You can also get free trials of Autodesk CAD and CAM software to play around with, or if you're a student, you can get the programs completely free. So, CNC machining is arguably the most significant manufacturing process of the 21st century, and its functionality drives technological advancement across the globe. It's a trade that is keeping up with the growth of technology, and machinists across the planet are